next round of presentations. All right. But we had a great morning of presentations. I'm expecting more good things this afternoon. We have a lot of exciting presentations for you this afternoon. If you can stay for more than one, we appreciate that. But with that, Dave, I'll let you introduce our next team.
Okay, we have Andrew Wright and Drew Lasme. Talk about their senior project.
Thank you, Mr. Evan.
Sorry. Thank you. Sorry. Very deep.
Okay, like Mr. Alex said, my name is Andrew Wright.
And I'm Guy Lasme.
And we did our senior design at Escalade Sports, implementing a semi-automated fulfillment line for their processing operations.
But first, let us give us a quick background of what is Escalade Sports business. The Escalade Sports is a company that has been around for more than 8 years. They are located here in Evansville, and they're located here in Evansville, like I said, and near the historic Bossy Stadium. Escalade Sports specializes in manufacturing and distributing sports goods. Here on the right of this slide, you can see the brands that Escalade Sports owns or partially owns. And on the left side here, you can see the biggest customer, or let's say the main customer, that retails Escalade Sports products.
So the reason that we're doing this project is because of the growing trend in Escalade Sports over the past few years. In 2012, they processed 400,000 cartons per year. For 2015, they're estimating that they will process 1.1 million cartons for the year. Now, with that increase in volume, they're going to have, if they continue going under the same conditions that they're processing right now, they will have increased labor and increased labor hours. And also, they'll increase the amount of chargebacks per year in order to process that out.
In order to solve the problem Andrew just mentioned, our liaison, Gary Mahone, thought it will be imperative to make the change we needed in the picking area at the distribution center. This is actually where the accessories we're selling, we're selling to a customer is picked. This is our picking area. This is the layout of our actual picking area. It is organized in 3 lines. Each line corresponds of one of our customers. For instance, here you have the Sport Authority line. This one is the Dick's Sporting Good line. And the last one is Target and Walmart line. Each line has a conveyor in the middle and pallets 3 feet away. 3 feet away, sorry. Where like the employee gonna pick the item that we need to ship to our customer.
So for the existing operation, first it starts with the caller. Okay? They're going to have a stack of sheets for the entire day's worth of order, and they will actually call out on a per-line basis to the picker, right here. But then the picker will go to the appropriate pallet that is staged on the line and pick that called out item. Place them on the pallet conveyor, which will then travel down to the labeler. And the labeler's job is to place the label correctly on the cartons, because otherwise, if it's incorrect, those cartons will be charged back to Escalade Sports by their customers. So after those cartons have been properly labeled, we will then go to the palletizer. And the palletizer is a very, very important step in this process, because currently right now, for example, the palletizer will have 5 cartons that will be presented to him. And he will have to figure out how to put them correctly on a pallet, because those cartons will be of 5 different box shapes, sizes, and weights. So you have to try and figure out how to fit them on the pallet with the least amount of wasted space as possible. And that's what this picture right here represents. This is right now what a full pallet will look like after it's been shrink wrapped. As we can see, there are quite a few areas where there's gaps in between the cartons because they don't quite match up perfectly.
For hours of observation, we were able to create a spaghetti diagram that traces the state of the most mobile person on the line, which is the picker. This is here a 30 minutes observation sample, right? You can observe in some location the picker is picking more than others. How can you explain that? Let me give you a quick example. Say in our picking list, we have 50 tennis ball boxes that need to be picked on our picking list, I said. The picker will go back to that location where we have the tennis ball box 50 times. The next slide is just to show you something you can also observe. We choose also another 30-minute sample here. You can see the color can sometimes tell the picker to go pick a box, a product in a different existing line we have in the picking area. In this example, the color told the picker to go pick an item in the TSA line and bring it back in the sporting good line.
At first, Guy and I were calculating the average throughput times per operator. We presented this information to our liaison, and he instructed us that the type of improvement we're going to be doing is going to reduce the amount of processing time by hours, not seconds. So the detailed throughput cycle times is not exactly what we need to go. And he showed us right here on the right, this chart. It's a simpler way of doing this, and it's very simple. I'm going to walk you through it real quick. First, you get a starting and ending time, and then you subtract out the total break time that was in between. Then you go to the traffic office, and you ask them how many cartons did they process for that order. They'll give you that total amount of cartons. Then you take that total amount, divide that out by the amount of minutes it took them to process that entire order, and that will give you your average cartons per minute. Thing to note about this is it includes downtime and changeover times. But we also wanted to look one more time at comparing the two different time studies that we did. They actually resulted in very similar cartons per minute. This is pretty significant because when we were doing that individual detailed time study, we were actually calculating or figuring they were doing what they were actually doing average throughout the entire day's worth of information. So for the metrics, first we started off by figuring out how much it costs per minute. Then our liaison told us that in 2014, they will process a little over 1 million cartons. So given that, you can calculate out how much total minutes Escalade will have to work in order to fulfill that volume, which ended up being 245,000 minutes for the year. Now we can calculate the total direct labor cost on the line, which is distributed out over 4 operators, to $320,000.
Now we're moving to the second phase of our project, which is to discuss the proposed new picking area operation. Again, our liaison, Gary Mahone, suggests that we follow up with the company, Lumina Group, which is a company that specializes in warehouse distribution system. Our liaison gave us the element in which to see in the line to improve the future picking process. Our main job for Andrew and I was to design a new operation that will to design an effective operation that will respond to the demand, that will satisfy, the increasing demand that Escalade Sport is right now experiencing.
So the heart and soul of the proposed Numina line is the RDS system, the real-time distribution system. In short, this system will take that entire day's worth of order and compile it down to one page and sum up each item into one line, which it will then tell the picker over a headset how much to pick and place on the line, in which those cartons will then travel where the application section of the RDS system will take place. This is where they will first be scanned to make sure that the right cartons are being picked. After they've been scanned, they will then, the RDS system will print and apply the label directly onto those cartons. And after those labels have been applied, it's going to end with a final vision system to verify that those labels are placed in the correct location. Again, to emphasize we're trying to reduce the amount of chargebacks per year. So after all that, those cartons will travel down the line to a diverting system, which will divert out to 3 palletizers, or however many palletizers we have on the line at that time, in a round-robin manner.
Okay, this is our proposed layout for the future state. And you and I will design. Sorry. While designing this new layout, we decided to keep the exact same footprint of the existing picking area. And we also think it will be economical for us to use the same equipment that already exists in this picking area and also in the entire distribution center. For instance, the conveyor you see here is a combination of the TSA, the Sport Authority conveyor, and the Dick's Sporting Goods conveyor that you see in the previous slide that we put together here. And the racking system we designed here was racks that that Escalade Sports obtained when they bought a company in Pennsylvania recently. We just used them to design our new racking system. Here. Regarding now the operation, I'm going to repeat a little bit what Andrew said, but I'm going to give you a little visual to see what's going on, what's going to happen. The picker is going to pick a product from the rack here that it will dispose the box on the conveyor, which is powered. It will go toward the inline industrial barcode label, who's going to seize the box and print and put apply the label, and then it's going to be scanned here before it is diverted to one of the palletizers. In case the box was wrongly labeled or it was not the box we wanted to pick, it's going to end up here at the end of the secondary conveyor, where like the picker can come and collect it later.
So this is the proposed spaghetti diagram. An important thing to notice is that the operator is now moving in a more linear fashion. Okay? This is achieved by programming the RDS system to know exactly where each pallet is located on the line. The red boxes around those white pallets represent an industrial staging racking system that Escalade has previously acquired. It's a 3-tiered system that we're going to use, and what it does is allows us to be able to stage the same amount of pallets as we are currently, but we're going to use up less floor space to do so. For estimating our future cycle times, first we contacted the Newman Group, and they instructed us that the automation of their line will be able to process 15 cartons per minute, and that equates out to 4 seconds per carton. Now, with the new process, we're relocating our labor to do 2 functions. 1, picking, 2, palletizing. So first, the picker is actually going to be picking at, we think, an average of 3 seconds per carton. And this is because they'll be able to pick, or we're eliminating most of that walking time that they were doing before. Now for the palletizers, we have 3 palletizers. We need that amount of palletizers in order to keep up and be able to utilize the Newman line as efficiently as possible. And so we're also estimating that the palletizers will be able to pack 20% faster. The reason for this is because they'll be palletizing similar cartons. They're going to receive a lot of the same product, and it's very, very easy to pack the same boxes as opposed to the varying boxes that they were packing before.
Now the proposed statement. We are expecting, based on the new line we're going to implement and the information Lumina will give us, to see our cycle time triple. Our average cycle time, triple. It used to be 4.4, almost 4 cartons per minute. It's going to be 15 cartons per minute now. And based on the total estimate carton, we estimate to peak in the year 2014, which is 1,030,000 cartons. We expect to only spend 69,000 minutes this in 2004 to pick all those blocks. This obviously will directly affect our total labor cost. It will cut it. It will decrease by at least 1/3. Only if you guys remember, it used to be 320,000, and now our total cost per year is going to be 90,000 per year. Now let's move to we're gonna do a quick comparative study, which if it just which justify the improvement in the picking area will know if the proposed line is implemented. The flow chart here shows that a manual fulfillment line increases the chance for defect to occur. Instead of having all the information split and split and all dispersed, what we're going to observe, what's going to happen is the information will all go in the RDS system database. And this gonna carry all the information that we need in order to build our product, to build our picking process. And with the new technology we're going to incorporate to the line, we are going to be able to relocate the labor and also the color to the palletizing process. Or anywhere else, matter of fact, in a plant, in a distribution center. So this creates, of course, now we can see on this flow chart a distinctive unidirectional flow of material throughout the picking process.
Let's take a look at the numbers one last time for our economic analysis. We included the chargebacks that we spoke about earlier. If nothing changes and they continue to do things the way they are, they will have $47,000 worth of chargebacks for the year. And that number is based off of the previous year of 2013. If we implement the proposed Numina line, we are estimating that that number will be reduced by 95%, bringing it $2,000. Now to totally implement the Numina line, it's going to cost $368,000. And this includes equipment, setup labor, testing, and training. Now, we're going to divide that out by the savings, which we calculated from comparing the current state to the future state, and that comes out to a payback period of 1.34 years, and also an ROI of 74%.
Now, our recommendation. Based on the number we just presented to you, the first recommendation we can always say is to implement this semi-automated fulfillment line as soon as possible. And the second one will be to organize the way we store the picking product based on the weight. The heaviest boxes have to be picked first, so they're going to be palletized first. And this is going to help us create more stable pallets, but also it's going to help us to decrease the chance of having damaged boxes or crushed boxes that arrive to our clients.
The last recommendation that we have is this idea of cross-docking. With the business trend that it's increasing at the rate that it is, in the next coming years, they're going to process roughly 1.5, maybe 2 million cartons per year. And if they continue to want to store them in their warehouse, possibly you're going to need more floor space to do so. And that's not always economically feasible. So that's where cross-docking comes into play. Cross-docking is a simple concept of the products are coming in from the receiving truck and they immediately go into shipping lanes. And they're not being stored. And so you're shortening up your shipping windows, okay, to be able to suffice for that increase in demand. And what that results is you have lower inventory in your house, but you're also, like I just said, able to keep up with demand. The conclusion of our project was it was actually implemented. Or is it going to be actually implemented? It was approved. Our liaison took the information that we gathered in the first phase of our project and presented it to the board of directors of Escalade Sports, and they gave him the green light. And the Numina line is supposed to be in full production by the end of August of this year.
We want to acknowledge now all the people who helped us to make this project happen. Dr. Marco Taragracia, Dr. Thomas McDonald, Dr. Zane, Mr. Eller, our liaison, Gary Mahone, and the distribution center staff, the Numina group to share the technology, and Dynamo for assisting throughout the project.
So that concludes our presentation. We now open the floor to any questions.
All right. Questions?
Thank you, gentlemen. My question is, you've got the time studies and everything you exampled, or the
and everything you examined started with the line. But one of the things that the picker does is not walk around as much. And therefore, there must have been some extra planning that went into your new proposed line before to get the picker in the right order. Have you accounted for that time, or is the picking part really the bottleneck?
Well, actually, no. To answer that question, is the picking part really the bottleneck? No, the palletizing is actually what took the most. And you would think that the picker, under the existing conditions, would be, but that walking time, what did not overweigh the amount of time it took to really think out how to palletize right now. But to answer your question, that's what the RDS system will do. Okay, and so you program that system to know exactly where each item is staged on the line. Okay, and not only do you do that, but when you have your entire day's order, they actually will enter it into the RDS system, and it will run, process, and it will spit out a concise order on one sheet, and it automatically knows, okay, you're going to start on the very first pallet. Let me show you. Let me go back to that proposed state right here. You're going to start on the very first pallet, for example, will be that pallet right there. And the RDS system will know this item is on that pallet. Okay, now take 60 cartons from that pallet. Once you're done with that, you're going to move to the next pallet, which is the next item in the order.
What if the heaviest one isn't on that first pallet? I mean, so somebody has to decide with the fork truck to put it there.
Yes, and that's where we proposed as a recommendation in the future. For starters, we're implementing a new line. There's going to be a lot of troubleshooting, so we just really want to get this system to work. But maybe next year, reapproach the software configuration and maybe say, all right, now that you know the information, now that you know the order, now I want to say, okay, let's put the heavier cartons first because we don't want the heavy cartons on top, possibly damaging our products.
Andrew, would you go to the slide? Which slide? Where we have the existing operation. Yeah, something we didn't mention, we didn't want to talk about is the setup. During the setup, we have a clerk. The clerk here on the clerk is a person, we have an excess store, they have the luxury, I should say, to have 3 days of setting time. And during that time, we have the clerk who's in charge of saying, okay, he's the one who's going to enter the information, the RDS system will need to know how we can, where we should have our product disposed to be picked or not.
So someone already does that?
Yeah, somebody already does that. It's not like something, yeah.
So that part of the production is no additional time, no additional organization?
No, we have enough time to set up.
Can I help with that? Let me just clarify. Those inventory locations are static. So it's not a choice for the person to put stuff there. It always goes to the same spot. That's how RDS knows. Always A1 is T1701. Okay. And so we build it from the very beginning. Largest, heaviest cartons moving that direction. We always start here and pick in that direction every single one that comes to the shop.
Okay, so that organization already is. I see that.
When you were looking at the RDS, you took Numina's number of 15 cartons per second. Now, is that based on a standard size box, or is that allowing for the fact that you've got multiple size boxes with multiple weights in completely different dimensions? Because different boxes, you can't always move at the exact same speed depending on the box size.
And actually, to answer that question, I do believe that we didn't quite ask them that specific question. But from what they were telling us, it does sound like this RDS system, it already has, we do know every single box carton and its dimensions and its weights. And so we can actually enter that information into this RDS system, and it will automatically know, okay, now you're running, TS 1-800s or whatever, and it will know exactly these are the dimensions, this is how much it weighs. But one thing that actually does happen is our conveyor, that what they sit on, runs at a constant speed, and that never changes. And so that is actually, the speed is based off of that conveyor, which only runs at, I think we found it like a mile an hour, so it's very, very slow, but that's where it bases it off of.
And I want to add to this that I personally, my first project when I worked at the Escalade Sports was to weigh all the products we have this time. And there's no, and the weight of those products are not so important that they can really influence the speed and luminal, the cycle time as the luminal moves.
Nice job, guys. I'm curious, you mentioned that there's still some room for expansion here. What would you recommend as the next big step? Would it be something about accounting for the weight, or maybe the organization on the pallets?
Let me bring this up, okay. I'm sorry, can you rephrase that question, please?
Sure, I'm just curious as to what the next step would be regarding where you ended up. It sounds like there's still some issues with weight in terms of getting the heaviest stuff first to get it on the bottom of the pallet. It sounds like there's still some organization problems in terms of getting this the right size organized, the right size boxes in their organization on the pallets. What would be the next step?
The way we design those racks where we're going to store the parts, is to make it flexible for the management or the supervisor to kind of, we want to give them the flexibility to organize this area. We didn't want to impose a way they should do it. And when we recommend that we should do it based on weight, it's a suggestion. It's a suggestion because, like I said, the weight of the boxes are not so important that we have to do it. But who knows what's tomorrow going to be, because SL Sport is keep buying new businesses. What are the new products we're going to have? And how this weight can influence our business tomorrow. This is our recommendation. This is kind of like to foresee the future.
Yeah, and maybe to expand upon that, the next step would be is, now that we've got it in here, it's been running, it's been working, we're processing much faster, we're working out those bugs of the entire system, is to, okay, now that we've got it here, and we're still continuing to increase our overall volumes per year, what can we do next? Do we want to implement another line? Do we want to totally rethink our warehouse capabilities? Do we want to store everything in the warehouse, or do we want to just try and send everything out real quickly and provide to our customers instead of 5 to 7 day shipping windows, maybe down to 2 to 3? So that would be the next step. It would be take this line and possibly create more of them. Because this is just one aspect of this warehouse. There's also what we didn't quite mention, but they also have a .com line which processes online orders, .com. And so possibly we could even introduce that line into this one. So I hope does that answer your question? Okay.
Andrew.
Yes.
Andrew, great presentation. Can you show the palette, that one? I think that is not a question, it's a comment. Additional savings will be achieved in transportation. Once that you have all those uniform boxes, uniform dimensions, you will be able to ship more, use more cubic space inside the trailer, so, additional savings will come from there. And the second is also a comment. Do you know that Academy Sports is coming to town? Academy Sports is a store that is very popular in Texas, Alabama. I think it will compete with Dick's Sporting Goods. When we were living in Texas, we saved a lot of money going there. It's going to be located next to Sam's Club, in that area. So to give an idea, the soccer shoes that we purchased at Dick's, like $134, I paid for that. My wife didn't know, of course. But in Academy, you can buy those for $95. So I think that the people in the area will benefit a lot from this second alternative.
Absolutely, absolutely.
Thank you.
And I want to say, I think we deliver. We work. We build the Academy is one of the customers of SL.
Oh, already? Okay.
Yeah, big time.
All right, folks, let's give them a hand.